Okay, hello everyone. So since we have already completed resistance in series, Ohm's law, drift velocity, so moving forward, our next topic is resistance in parallel. So first we'll discuss how to find out whether resistance are in parallel or not, then how to find out distribution of current, how to find out equivalent resistance. The derivation is very important. So resistors are connected in parallel when potential difference across them is same. Now how to find out whether potential difference is same or not. So suppose the resistor R1. The resistor R1 is there. So if I put a point before R1, suppose it is to be A, and a point after R1, suppose this point is B. Remember, from this point till this point, so between these 2 points, there is no battery, there is no resistor. So this point will also be A, and this point will also be what? B. And if this point is A, then this point will also be A, and this point will be B. Now if you'll see, point across all three resistors is same. So across R1 points are AB, across R2 points are AB, and across R3 points are AB. So when points across resistors are same, the resistors are said to be connected in parallel. So across R1, across R2, across R3 points are same. But if you'll see, the current is not same. Current will depend on the value of resistance. So from a battery of potential V, suppose I current is there, and the I current will reach at this point and it will get divided into three parts. It is I1, I2 and I3. I will be equal to I1 plus I2 plus I3, because at any point the total current that is incoming will be equal to the total current that is outgoing. Now how to find out the equivalent resistance? Suppose same circuit, so the potential difference of battery is V, and suppose in R1 resistance the current is I1, in R2 resistance the current is I2, and in R3 resistance the current is I3. But in parallel, potential difference across the resistor is same. So in first resistor the potential difference V will be I1R1, in second resistor the potential difference V will be I2R2, and in third resistor the potential difference V will be I3R3. And if you'll see, the potential difference across R1 will be equal to the potential of battery, because between the battery and the resistor there is no another electrical component. So V will be equal to I1R1, V will be equal to I2R3, and V will be equal to I3R3. All these three equations are important when you will solve questions related to find current in individual resistor. Now we have already derived this equation, that is V equal to I1R1, V equal to I2R2, and V equal to I3R3. So I1 will be V by R1, I2 will be V by R2, and I3 will be V by R3. Now always remember this equation, that is V equal to I into R equivalent. Here V is potential difference due to battery, I is current, and R equivalent is equivalent resistance of the circuit. So I can be written to be equal to V upon R equivalent. Now using this equation, that is I equal to I1 plus I2 plus I3, that the current reaching at this point is I, and the current will be divided into three parts, that is I1 plus I2 plus I3. Substituting all the values, the value of I, the value of I1, the value of I2, the value of I3, equivalent resistance will be 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Don't forget to take the reciprocal, at the last step. People generally don't take reciprocal. So 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, suppose in this circuit we have a battery of 4 volt and there are two resistors, 2 ohm and 4 ohm. So I have to find value of I, I1, I2 and R equivalent. See, first we calculate R equivalent. So 1 upon R equivalent will be equal to 1 upon R1 plus 1 upon R2. So 1 upon R equivalent will be equal to 1 upon 2 plus 1 upon 4. Taking LCM, R equivalent comes out to be 4 by 3 ohm. So this is the equivalent resistance. Now I1 will be equal to V by R1 because V is equal to I1 R1. So I1 will be 4 by 2 ampere. I2 will be V by R3, it is 1 ampere. So total current I is 3 ampere. Now I is equal to V by R equivalent. We can again calculate I using some another method. I is also equal to V by R equivalent. So 4 upon 4 by 3, the answer will be 3 ampere. So if we'll see, this 3 ampere and this 3 ampere is basically same. So you can find out R equivalent using two methods as given in this question. Now always remember, here in this question I have put I1 equal to V by R1. You can only use this equation when there is resistor and battery directly connected to the resistor. It means, if you'll see, the negative terminal of the battery is connected to the resistor and the positive terminal of battery is also connected to the resistor. If suppose there is another resistor here, then you can't use this equation. Then we have to use Kirchhoff's first law and second law. So always remember when you can use this equation and when you can't use this equation. Okay, here's another example. So suppose in this circuit we have a battery of potential difference V volt. The current is I from battery and the current is divided into three parts: I1 from 2 ohm, I2 from 4 ohm and I3 from 6 ohm. And in the question it is given that I3 is 2 ampere. So current in 6 ohm is 2 ampere. Find I1, I2 and V. Now remember, in 6 ohm the current is 2 ampere. So in 6 ohm the potential difference will be I3 R3, that is 12 volt. But in parallel potential difference is same. So for across 4 ohm also the potential difference will be 12 volt and across 2 ohm also the potential difference will be 12 volt. So for 4 ohm we can put V equal to I2 R2. So V is 12, I2 into 4. Since resistance is 4 ohm, so I2 will be 3 ampere. And similarly, if we put the values in for the first resistor, that is V equal to I1 R1, V is 12 volt, I1 and R1 is 2 ohm. So I1 will be 6 ampere. So with this way, you can find out current, you can find out R equivalent, you can find out potential difference. Okay, now what you do is you to submit an online quiz that is there in the description below and also with the message of this video. If you have any doubt, you can send me. Okay, thanks a lot.